Algebra 2 Honors, Lesson 11.3, Geometric Sequences. So we've done arithmetic, we added up. So geometric really not that complicated. How do we get from 8 to 20? How do I get from 20 to 50? How do I get from 50 to 125? It's not clear on these, but I'll show you real quick in a minute how to do it. It's multiplying by, boy, I think I would have prepared better for this, by 5 halves. There you go. So the next two terms would be 125 times 5 over 2, 625 halves. The next term would be that times 5. I believe that's 3125 over 2, so we'd have over 4 over 2, 3125 over 4. And this is a conjecture, but it turns out it's accurate, so somebody needs to confirm with us this is a geometric sequence. Remember, sequence, just a list. Series, we'd be adding them up. But that's it. It's just multiplied by the previous one. This number we multiplied above is called the common ratio. And it's given the R. To find it, R equals 20 over 8 equals 50 over 20 equals 125 over 50. And of course, you only have to do one of these so that you find out R equals 5 halves. All right, and that's really it. That's really it. You want a formula for finding things? Great. Very similar to the other one. Our first value times the ratio, but with the numbering system we have to go n minus 1. So that's it. Problems. Find the eighth term, a of 8. a1 equals negative 3. Negative 2 to the 8 minus 1. Get some mildly big math here. You end up with negative 3 times negative 128. Negatives cancel and we get 384. These numbers will pop up regularly, 384, 540, 625, things like that. How about writing an equation for the nth term of the geometric sequence? Well, what's A1? 3. Common ratio. Easiest one looks like 12 over 3 is 4. We're done. A, n, 3 times 4 to the n minus 1. That's it. You may or may not notice this looks an awful lot like a exponential formula, which I believe was y equals a times b to the x. So isn't that interesting? These two have a fair amount in common. Arithmetic looks like something, but I don't know if anybody noticed. Another time. So some practice. Find the 10th term if I give you A4 and R. Well, you have to, I'll rewrite it. You have to figure out what's going on here. A4 is 108. A1 we don't know. We need that. R is 108. Isn't that interesting? They're both 108. That's a mistake. Let's make that R equals 3. To the n minus 1, which in this case is 4 minus 1. I keep making this mistake. I should actually write that in. N equals 4. So 108 equals 27 times A1. A1 equals 4. So now we have our formula. We want the 10th term. A10 equals 4 times 3 to the 10 minus 1. A10 equals 7, 8, 732. I'm going to check that. I'm working off of memory. Looks good. You can also find geometric means. I always make a note. Hey, didn't we do this? No, we did arithmetic means. Lots of different ways to do this. My students always want me to just blast it out with a formula, so I will. A1, A1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 576 equals 2.25 r to the 5 minus 1. 256 equals r to the 4th. I happen to know that 4 to the 4th is 256. So now I found my r value. Now here's the funny part. I'm done. If you just want me to find these values, then I'm not going to do anything flashy. 2.25 times 4, 9 times 4, 36 times 4, 144. And the beautiful thing, I just multiplied by 4, and it gives me 576. Check, so I don't have to think about it at all. Try this one on your own. All right, I will do it now. 1.5 equals negative 48 r 1, 2, 3, 4, 5, 6 to the 6 minus 1. I get 1 negative 1/32 equals r to the 5th. Take the 5th root of both sides. I get r equals negative 1/2. So negative 48 divided by negative 2, positive 24, negative 12, 6, negative 3, positive 1.5, works. So that's geometric sequences. Just a little bit more language. Math really isn't all that hard. Good luck and happy mathing.